Welcome to the very first episode of Blueprints of a Tech Org, Roles, Ranks, and Roadmaps.
We're kicking off a 10-episode series designed to be your practical role-by-role guide through the intricate machinery of modern technology organizations. We'll be charting the entire map, from the individual contributor ladder in engineering through technical and people leadership all the way up to the executive suite.
We'll also unpack crucial adjacent roles in product, program management, data, and design, and we'll constantly be looking at how these roles shift and adapt depending on the context, whether you're in a scrappy startup, a FAANG-scale behemoth, or a more traditional enterprise company. Our goal is to illuminate the responsibilities, the success metrics, and the collaboration patterns that make tech teams tick.
And there's no better place to start than the very first rung on the engineering ladder. It's the point of entry for so many, yet it's often misunderstood. We're talking about the junior or entry-level software engineer.
Exactly. The title seems self-explanatory, but what does it actually mean to be a junior engineer in a professional setting? What's the real job description beyond just writes code? And how does that first crucial 0 to 2 year period set the trajectory for an entire career?
Those are the core questions we're exploring today. We'll break down the day-to-day responsibilities, what success actually looks like when you're just starting out, and how the role differs dramatically between a nimble startup and a tech giant like Google or Meta.
Let's start with the absolute fundamentals. When a new graduate or a career switcher lands their first engineering job, what is the primary expectation? What are their core responsibilities?
The single most important phrase to understand about the junior engineer role is under close guidance. Their main responsibility is to write well-defined code and the tests that go with it. They are not expected to invent solutions from scratch or design complex systems. Instead, they are given small, clearly scoped tasks. This could be fixing a specific bug, adding a small UI component based on a detailed design, or implementing a single API endpoint with a very clear contract.
So it's less about architectural vision and more about precise execution on a small scale.
Precisely. Think of the organization's codebase as a massive, sprawling city. A senior engineer might be designing a new bridge or a new subway line. The junior engineer is tasked with perfectly laying a specific set of bricks for a single building's facade, with the blueprint and materials already provided. The focus is on craft and execution at a micro level. Their world revolves around learning the fundamental tools and practices of the trade, becoming fluent in the primary programming languages, mastering the team's version control system like Git, and understanding the rhythm of the development cycle.
That brings up a key point, the code review. This is often a huge part of a junior engineer's experience.
It's arguably the most critical part of their learning process. A junior engineer's initial contributions are a vehicle for feedback. They write code, submit it for review, and a senior member of the team provides detailed comments. This isn't about criticism, it's about mentorship and calibration. The feedback will cover everything from simple style conventions to more complex topics like performance, security, and maintainability. Their responsibility isn't just to write the code, but to actively absorb and apply that feedback.
It sounds like the role is almost an apprenticeship. The primary output isn't just the code itself, but the development of the engineer.
That's the perfect analogy. A junior engineer is an apprentice. Imagine a master woodworker's shop. The apprentice isn't asked to design and build a complex wardrobe on day one. They're given a specific task: learn to make a perfect dovetail joint. They'll be shown the tools, the technique, and the standard for quality. They'll make it once, and the master will point out the flaws. They'll make it again and again until the joint is clean, strong, and precise. The junior engineer is doing the same, but their dovetail joints are well-written functions, clean components, and thorough unit tests.
And what happens in this analogy when the apprentice cuts the wood wrong? In software, there's no wasted material, but there are bugs.
The wasted material is time, and the cutting wrong is introducing a bug. That's why the scope is kept small. A mistake on a small feature or a bug fix is a low-risk learning opportunity. It's caught in code review or by automated tests. This supervised environment is a safe space to fail and learn. The expectation is that the apprentice won't make the same mistake repeatedly. Their growth is measured by how they integrate the lessons from those mistakes into their next piece of work.
This seems to align perfectly with how big tech companies structure their entry-level roles.
It does. If you look at the official career ladders, the language is very consistent. For example, at Google, an L3 engineer, which is their entry level, is expected to focus on coding fundamentals and debugging, and they operate under strong mentorship. Meta's E3 level is virtually identical in its expectations.
And it's not just Google and Meta. Amazon has a similar structure.
Exactly. At Amazon, the entry-level role is an SDEI, which corresponds to their L4 level. The internal documentation and public guides consistently state that an L4's focus is on executing well-defined tasks with guidance. The theme is universal across big tech. You are here to learn the company's way of building software, to master the core tools, and to prove you can be a reliable executor on clearly defined problems before you're given more ambiguity and scope.
With that in mind, how is success actually measured? It can't be based on the number of features shipped because their scope is intentionally limited.
That's a crucial distinction. The success metrics for a junior are different from any other role on the ladder. They fall into three main categories. First is code quality. Is the code they write clean, readable, and does it adhere to the team's established patterns and style guides? It's not about being clever, it's about being clear. Second is the timely completion of tasks. Can they take a small, well-defined task, estimate how long it will take, and deliver it within that time frame? This builds trust and predictability.
And the third, which sounds like the most important.
The third is simply growth. This is the metric that matters most to a good manager. Are they improving? Is the feedback they receive in code reviews changing over time? Initially, comments might be about basic syntax or logic. 3 months later, the comments should be about more nuanced, higher-level concepts. Are they asking insightful questions? Are they starting to navigate the codebase more independently? A successful junior engineer has a steep, positive learning curve. Their value is measured not just by what they produce today, but by their demonstrated potential to produce much more tomorrow.
So the role is a proving ground for their ability to learn and adapt within a professional environment. How does this play out in different types of companies? Surely the experience of a junior at a 500-person startup is different from a junior on a team at Microsoft.
The difference is night and day, and it represents a fundamental trade-off. Let's start with big tech. A typical team of 6 to 10 engineers might have 2 or even 3 junior engineers. This is possible because there are usually several senior and staff engineers available to provide structured mentorship. The onboarding process is often highly refined, with boot camps and dedicated training. A junior there will likely work on a very small component of a massive system. They'll learn best practices for writing scalable, resilient code at a level that most smaller companies never have to think about. The learning is deep, but it can be narrow.
You become an expert on one very specific gear in an enormous machine.
A perfect way to put it. You'll understand that gear better than anyone, but you might not see how the entire machine is assembled for quite some time. The guardrails are high, and the support structure is immense. Now, contrast that with a startup. A startup might only have the budget or need for 1 or 2 junior engineers on a team of, say, 10. Mentorship is often ad hoc and opportunistic. You grab time with a senior engineer when you can.
The pace must be completely different.
Entirely. On day 1, you might be asked to touch the database. On day 2, the front end. On day 3, the deployment scripts. The exposure is incredibly broad. You see the whole machine from the very beginning. You learn to be scrappy and resourceful because there isn't a pre-paved path for every problem. This environment forces a rapid sink or swim style of learning. It can be exhilarating and lead to incredibly fast growth for a certain type of personality.
But it also sounds riskier. Without those guardrails and that structured mentorship, there's a higher chance of picking up bad habits or feeling completely overwhelmed.
That is the core trade-off. Big tech offers structure, depth, and a safety net. Startups offer breadth, speed, and a high degree of autonomy much earlier in your career. Neither is definitively better. It's about aligning the environment with your learning style and career goals.
So, to summarize, the junior engineer role, at its heart, is a transitional phase. It's about moving from the academic understanding of computer science to the professional craft of software engineering. It's an apprenticeship where the primary goal is learning, and success is measured by the velocity of that learning.
That's the key takeaway. Whether you're in a startup or a tech giant, the mission for the first 1 to 2 years is the same. Be a sponge. Absorb the technical patterns, the team's communication style, and the company's culture. Your job is to master the fundamentals of execution and collaboration to build a foundation of trust. The code you write is important, but the engineer you are becoming is the true measure of your success in this role.
This phase of intense guided learning is all about building that foundation to take on more responsibility, to be trusted with more ambiguous and complex problems, which brings us directly to the next step on the IC ladder, the mid-level engineer. What happens when the training wheels start to come off?
Exactly. That's where the journey gets really interesting. In our next episode, we'll explore how an engineer makes that critical transition from executing well-defined tasks to owning complete features, from following designs to actively participating in them. We'll dive into the world of the mid-level engineer, the role that truly forms the backbone of almost every engineering team.
Welcome to Blueprints of a Tech Org, Roles, Ranks, and Roadmaps. In our last episode, we laid the foundation, exploring the world of the junior engineer, a role defined by learning, guidance, and executing well-defined tasks. But what happens when the training wheels come off? When an engineer is no longer just fixing bugs or building small components, but is expected to take a feature from an idea to a fully functioning part of the product?
That's the critical transition we're mapping out today. It's the journey from apprentice to journeyman, from learning the tools to skillfully wielding them. We're talking about the backbone of most engineering teams, the mid-level engineer. Today, we'll dissect what it truly means to own a feature end-to-end, how success is measured when you're no longer a junior, and how this role functions within the ecosystem of a startup versus a big tech company. Understanding this stage is crucial because it's where individual contribution truly begins to solidify and have a measurable impact.
Exactly. This isn't just about writing more complex code. It's a fundamental shift in responsibility and autonomy. Let's start with that core concept of ownership. For a junior, a task is often a ticket in a backlog with clear instructions. For a mid-level engineer, the scope is much broader. What does owning complete features or services end-to-end actually entail day-to-day?
It's about taking a concept and being the primary driver to make it a reality. Think of it like being the lead carpenter on a specific room in a house being built. The architect, maybe a senior engineer or a product manager, has provided the overall blueprint for the house, but you are responsible for the entire bedroom. That means you're not just hammering nails. You're interpreting the plans for that room, figuring out the best sequence to build the walls, install the window, and wire the electricity. You're selecting the right materials, ensuring they're up to code, and coordinating with the plumber and the electrician to make sure everything fits together seamlessly. You are the go-to person for that room.
So, translating that analogy, the mid-level engineer isn't just handed a perfectly specified function to write. They're given a user problem or a product requirement, like users should be able to upload a profile picture. From there, they are expected to be a key player in the conversation. They need to think about the user interface implications, the back-end storage, how the image will be processed, and what the API should look like.
Precisely. This involves participating actively in design discussions. A junior might sit in on these meetings to learn, but a mid-level engineer is expected to contribute. They should be able to ask clarifying questions, point out potential technical hurdles, and suggest alternative implementations. They start to develop a sense for not just how to build something, but why it's being built a certain way. This also means writing code that is scalable and maintainable. You're not just building the bedroom for today, you're building it knowing that in a year, the owner might want to add a walk-in closet or install a ceiling fan. Your work has to be robust enough to accommodate future changes without requiring a complete teardown.
This seems to be where the collaborative aspect really kicks into high gear as well. The provided context mentions working with QA, product managers, and other teams. How does that differ from the junior experience?
The nature of the collaboration becomes one of partnership rather than mentorship. A junior might ask a QA engineer to help them test a ticket. A mid-level engineer, on the other hand, will proactively work with QA to develop a testing strategy for the entire feature they own. They'll anticipate edge cases and work with the tester to ensure comprehensive coverage. Similarly, with a product manager, the conversation shifts. It's less about receiving instructions and more about a feedback loop. The PM might say, "We need this feature," and the mid-level engineer can respond with, "I can deliver the core functionality in 2 weeks, but if we add this other element, it will take 4, but we'll also solve this other user problem we've discussed." It's a more strategic dialogue.
And this extends to mentoring juniors as well. It's the first step on the leadership ladder, even for an individual contributor.
It is. It's the see one, do one, teach one model in action. Having just navigated the junior to mid-level path themselves, they are perfectly positioned to help those coming up behind them. This isn't formal management. It's about being the first point of contact for a junior who is stuck. It's about providing constructive feedback in code reviews, not just pointing out syntax errors, but explaining the underlying principles of why one approach is better than another. This act of teaching solidifies their own understanding and is a critical skill for their own growth.
This is really well defined in the industry. For instance, at companies like Meta or Google, this role is often designated as an E4 or L4, respectively. At this level, the expectation is explicitly to deliver complete features or projects fairly independently. Amazon's L5 SDE2 has a similar scope, where they are expected to solve moderately complex problems and often take on the role of mentoring junior developers. It's a consistent theme across big tech. This is the level where you prove you can be trusted with a significant chunk of work and see it through from start to finish.
And that successful delivery becomes the primary measure of their performance. The success metrics shift from, "Did you complete your assigned tasks on time?" to, "Did the feature you owned ship reliably and on schedule?" The focus is on predictable, consistent output. This is why metrics like on-time milestone delivery and reliable feature performance are so important. It's not just about the code, it's about the outcome.
Code review performance is also listed as a key metric. Can you expand on that? Is it just about writing bug-free code?
It's much more than that. Of course, the quality of the code you submit is important, but just as crucial is the quality of the feedback you give in reviews. Are you catching potential issues in your peers' code? Are your comments constructive and clear? Are you helping to uphold the team's engineering standards? Excelling in code reviews demonstrates a deeper understanding of the entire code base and shows that you're thinking about the health of the system, not just your own small part of it. It's a sign of maturity and a prerequisite for moving to the senior level. It shows you're not just building your room, but you're also checking the work of others to ensure the whole house is structurally sound.
Let's talk about where these engineers fit into the broader organization. The context suggests that on a typical big tech team of 6 to 10 engineers, you might find 1 to 3 mid-level engineers. In a startup, however, the dynamic is quite different.
Very different. In a large company, the roles are more specialized. A mid-level engineer has a well-defined swim lane. In an early-stage startup, that concept barely exists. Most engineers, even if they join with only a couple of years of experience, are forced to operate at what is effectively a mid-level or even senior capacity very quickly. The team might only be 5 people total, so each person has to own massive parts of the product. They're not just a mid-level back-end engineer, they are the back-end engineer. They're probably also handling their own DevOps, doing their own QA, and talking directly to customers. They wear multiple hats out of sheer necessity.
So in that startup environment, the growth is accelerated by necessity, but perhaps without the formal mentorship structures of a larger company.
Exactly. It's a trial by fire. You learn incredibly fast, but you might also pick up bad habits or build things with significant technical debt because there's no experienced senior engineer there to guide you. In big tech, the path is more structured, the guardrails are higher, and the mentorship is more explicit. The trade-off is that the scope of your ownership might be narrower. You own a feature, not the entire payment system. Neither is inherently better, they are just different paths that attract different personalities and optimize for different skills.
It seems the core of the mid-level engineer's journey is this transition from directed execution to independent ownership. They become the reliable workhorses of the tech organization, the people who can be counted on to take a feature from concept to completion, ensuring the engineering team consistently delivers value.
That's the perfect summary. They are the engine room. While juniors are learning the ropes and seniors are steering the ship, the mid-level engineers are the ones keeping the propellers turning at a steady, powerful rhythm. They have moved beyond simply understanding how to code and are now deeply engaged in what is being built and why. It's a pivotal role that marks the full arrival of an engineer as a proficient, independent contributor.
And that proficiency sets the stage for the next major leap in a technical career. Once an engineer has mastered the art of owning a feature, the next logical question is, how do they start owning an entire system? How do they go from executing a vision to defining it?
And that brings us to our next episode. We will be charting the path to the senior engineer. This is where the scope explodes from a single feature to entire product areas. We'll explore how the responsibilities shift to system architecture, technical leadership, and influencing the strategic direction of the team. It's the transition from being a star player to becoming the on-field captain. Join us next time as we continue to map the blueprints of a tech org.
Welcome to Blueprints of a Tech Org, Roles, Ranks, and Roadmaps. We're mapping the intricate pathways of the modern technology organization, one role at a time. Last time, we explored the world of the mid-level engineer, the reliable engine room of the team, delivering features and honing their craft. But what happens when that engine is asked not just to run, but to help design the entire vehicle?
That's the critical juncture we're examining today. It's the leap from executing tasks to shaping the technical landscape. We're zeroing in on the senior engineer, a role that represents a pivotal transition in an individual contributor's career. We'll be breaking down their core responsibilities, looking at how tech giants like Google, Meta, and Amazon define this level, and exploring the metrics that truly define their success.
It's a role that's often misunderstood. Is it just about being a faster, more experienced coder? Or is there a fundamental shift in mindset and responsibility? This step is crucial because it's where an engineer's impact begins to scale beyond their own keyboard. It lays the groundwork for future leadership, whether that's on the technical or management track.
Exactly. The senior engineer is where leverage begins. They move from simply building the assigned pieces to questioning and defining what should be built and how. Their core responsibility is to lead significant, often complex, projects from conception to completion. This isn't just about writing code, it's about defining the technical solution itself. They are the ones in the trenches designing the system architecture, ensuring what gets built is robust, scalable, and maintainable.
So they're the ones holding the architectural blueprints for a major feature or service?
Precisely. And they're not just drawing them, they're ensuring the construction crew follows them. This involves actively driving code quality through rigorous reviews, setting standards, and establishing best practices for the team. They become the go-to person when a difficult technical problem arises. When systems go down in the middle of the night, the senior engineer is often the incident leader on call, the calm voice of authority who can diagnose the chaos and orchestrate a solution under pressure.
That speaks to a level of trust and technical authority that goes far beyond just being a proficient programmer. It's a guardianship role for the team's technical health.
It is, and that guardianship extends to the people on the team as well. A huge and perhaps the most important part of the senior engineer's function is mentorship. They are expected to actively coach and develop more junior engineers, helping them navigate technical challenges and grow their skills. They don't just solve the problem, they teach others how to solve it. This is where their influence on team strategy really comes into play. By elevating the technical capabilities of the entire team, they shape its future direction and potential.
I find that shift from individual contributor to force multiplier fascinating. It's a completely different way of thinking about one's contribution.
It's like the difference between being a master chef and an executive chef. A mid-level engineer is like a highly skilled line cook or sous chef. You give them a recipe, a feature spec, and they can execute it flawlessly. They know their station inside and out. They can chop, sauté, and plate with precision and speed. They can follow a complex recipe to produce a perfect dish every single time.
That's a great analogy. They own their part of the meal and they do it well.
Exactly. But the senior engineer is the executive chef. They don't just cook one dish, they design the entire menu. They think about how the appetizer complements the main course, how the kitchen workflow needs to be organized to handle the dinner rush, and which ingredients are the most cost-effective without sacrificing quality. They aren't just executing recipes, they are creating them. They're tasting the sauces, adjusting the seasoning, and most importantly, they're teaching the line cooks the techniques needed to execute the vision. When a new, challenging dish is introduced, they are the ones who perfect the process and then train the rest of the kitchen staff. Their success isn't just the one perfect plate they might cook themselves, but the quality and consistency of every plate that leaves the kitchen.
So their impact is measured not just by their own output, but by the output of the entire kitchen. They're responsible for the system, not just the components.
That's the perfect way to put it. They are responsible for the system. This is reflected in how major tech companies structure the role. At Google, an L5, their senior engineer level, is explicitly expected to lead projects, design complex systems, and directly influence the product's direction. It's baked into the job description. They are the technical authority on their project.
And we see a similar pattern at Meta with their E5 level.
We do. Meta frames it as owning a problem space end to end. That's a powerful phrase. It means the E5 is responsible for defining the technical vision for that entire area. They have to figure out the right path forward, drive the execution, and often this involves leading a small, informal team or mentoring several other engineers to deliver the results. The ownership is total.
Amazon's L6, or Senior SDE, seems to fit this mold as well, with a focus on leading significant projects and high-impact features. These aren't minor tweaks, they're the big, business-critical initiatives.
Correct. Across the board, whether at Google, Meta, or Amazon, the senior engineer is trusted with ambiguity and complexity. They are given a problem, not a task list. Their job is to turn that ambiguous problem into a concrete, well-designed, and successfully executed technical solution. They are the primary drivers of technical delivery within the team.
This brings us to a critical point. How do you measure the success of someone whose job is so multifaceted? It can't just be lines of code written or tickets closed.
Absolutely not. The metrics for a senior engineer shift dramatically from output to outcome. The first and most obvious measure is project impact. Did the project they led achieve its goals? Did it move the key user or business metrics it was supposed to? It's a results-oriented evaluation. The most elegant code in the world is a failure if it doesn't solve the user's problem or achieve the business's objective.
So a direct line is drawn from their technical leadership to the success of the product. What about the non-feature work, the architectural and reliability aspects?
That's the second pillar, system reliability. You look at the health of the systems they own. What is the uptime? What is the P99 latency? How many critical bugs or production incidents originate from their domain? A successful senior engineer builds systems that are not just functional, but are also stable, scalable, and resilient. They reduce operational load, they don't add to it. A key part of their legacy is the quality and robustness of the architecture they leave behind.
And the third pillar, I assume, goes back to the people aspect you mentioned earlier.
It's arguably the most important for long-term impact, the growth of the team. A key success metric for a senior engineer is the progress of their mentees. Did the junior engineers they mentored get promoted? Are other engineers on the team adopting the best practices they championed? Are they successfully delegating complex tasks and trusting others to handle them? A truly great senior engineer makes the entire team better. Their legacy is not just in the code they wrote, but in the engineers they helped build up.
That really crystallizes the transition. It's not just about your personal trajectory anymore, it's about the team's upward trajectory. How does this role fit into the typical team structure? Is there a standard ratio?
While it varies, a common structure in a healthy, balanced team is to have about one senior engineer for every 3 to 5 other engineers. This creates a good balance where the senior has enough bandwidth to provide meaningful mentorship and technical leadership without becoming a bottleneck. They can lead a significant project or feature area, guiding a few mid-level and junior engineers who are doing much of the hands-on implementation.
But this must be completely different in a startup environment.
Oh, completely. In an early-stage startup, almost every engineer is forced to operate at what is effectively a senior level, regardless of their years of experience. The environment demands it. You might have a team of 5 engineers building an entire product from scratch. Each one has to own huge, critical chunks of the code base. They have to make architectural decisions with incomplete information, manage their own project priorities, and deal with the operational reality of keeping the lights on. There's no one to escalate to. In that context, seniority is less about a formal title and more about the scope of ownership you're given.
So in a startup, the role is defined by necessity, whereas in big tech, it's a more formally defined step on a very long ladder.
That's a fair distinction. In big tech, the path to senior is a well-trodden one with clear expectations and competencies you need to demonstrate. In a startup, you're thrown into the deep and become a senior by virtue of learning to swim. Both paths are valid, but they produce different kinds of engineers. The big tech senior is often an expert in building scalable, reliable systems within a large, complex organization. The startup senior is often a master of pragmatism, speed, and navigating extreme ambiguity.
So to summarize, the senior engineer role is a fundamental pivot point. It's about shifting focus from personal execution to enabling the team, from writing code to designing systems, and from completing tasks to owning outcomes. Their success is measured by the impact of their projects, the reliability of their systems, and the growth of their teammates.
Exactly. It's the moment an engineer starts to truly scale their impact beyond their own 2 hands. They become a critical node in the organization's network, influencing not just the technology, but the people and the process around it. It's a challenging but incredibly rewarding step.
And it's a role that sets the stage for the next major leap in the individual contributor path. Once an engineer has mastered influencing their team and owning a large project, the next question becomes, how do you influence an entire organization? That's where we're headed in our next episode, as we explore the blueprints for the staff and principal engineer roles. Welcome to Blueprints of a Tech Org, Roles, Ranks, and Roadmaps. We've been tracing the path of an individual contributor in engineering, a journey of increasing scope and impact. Last time, we explored the world of the senior engineer, the backbone of the modern tech team, the person who takes a complex project and sees it through to completion.
Exactly. The senior engineer is the one translating vision into reality, leading projects and mentoring others. But what happens next? For many, this is where the path seems to fork or even vanish into the mist. It's a common misconception that the only way up from senior is to move into management, but there's another, deeply technical and profoundly influential path that remains purely within the realm of the individual contributor.
And that's precisely the territory we're mopping today. We're venturing beyond the well-trodden trails of the senior engineer to explore the peaks of the individual contributor track, the staff and principal engineer roles. We'll be dissecting what it truly means to operate at this level, moving beyond just leading a project to shaping the technical destiny of an entire organization.
We'll look at how the responsibilities fundamentally shift from writing code to creating leverage. We'll also examine real-world examples from companies like Meta, Google, and Amazon to understand what this looks like in practice. Finally, we'll discuss how success is measured when your impact is felt across dozens of teams, and how this unique position fits within the broader organizational structure. It's a critical blueprint for anyone wondering what lies at the pinnacle of technical mastery.
So, let's start with the core distinction. We left off with the senior engineer, who owns a large project or a specific product area. They design the system, they drive the code quality, they are the technical authority for their team's domain. How does the staff engineer role build upon, or rather transform, that foundation?
That's the perfect word, transform. It's not just more senior. A staff engineer's domain is no longer a single project or a single team's codebase. Their domain is the entire organization's technical landscape. They are expected to be an organizational-level technical leader. Their primary responsibility shifts from execution to leverage. They are multipliers.
What does that mean in concrete terms? When we say leverage or multiplier, what does a staff engineer do day to day? Are they still coding?
They might be, but it's not their primary function. A staff engineer spending 80% of their time writing code is often a sign that they're being misused or they haven't fully embraced the role. Their leverage comes from activities that scale their expertise. This includes writing high-level design documents that set the technical strategy for multiple teams.
It involves evangelizing best practices in security, performance, or reliability that raise the bar for the entire engineering department. And critically, it involves deep mentorship, not just of junior engineers, but of the senior engineers who are leading the individual projects.
So they're setting the technical vision, not just for a single product, but for how the company builds products.
Precisely. Think of it this way. A senior engineer is like the lead architect for a complex, state-of-the-art skyscraper. They are deeply involved in the blueprints, the materials, the structural integrity, and the day-to-day work to ensure that one building is a masterpiece of engineering. They own its success from foundation to spire.
A tangible, focused, and deeply complex responsibility.
Exactly. Now, the staff or principal engineer is the city planner. They aren't designing a single building, they are designing the entire city's infrastructure. They decide where the major highways go to ensure traffic flows efficiently between districts. They design the power grid that will support not just today's skyscrapers, but the ones that will be built 10 years from now. They establish the zoning laws, the architectural principles and patterns that ensure all the individual architects are building in a way that is coherent, scalable, and safe for the entire city.
I like that. The city planner doesn't lay every brick, but their decisions enable and constrain thousands of builders. Their impact is broader and more strategic. They have to anticipate future growth and challenges that no single architect is focused on.
And their success isn't measured by a single beautiful building. It's measured by the overall health, efficiency, and growth of the entire city. Is the city resilient to earthquakes? Can it handle a massive influx of new residents without grinding to a halt? Can new districts be developed without having to tear up the entire existing infrastructure? That's the lens through which a staff engineer's work is viewed.
This seems to map directly to how we see the role defined at major tech companies. For instance, at Meta, their staff engineers, at the E6 or E7 level, are described as influencing engineering efforts across multiple teams and helping to set team roadmaps. That sounds very much like a city planner coordinating between different construction firms.
It is. They are the connective tissue. When two different teams are building services that need to interact, the staff engineer is often the one ensuring the integration is seamless, performant, and aligned with a long-term architectural vision. They prevent the silo effect, where each team builds its own skyscraper without considering the shared power grid or road system.
And at Google, the emphasis for their L6 staff engineers is on large-scale designs and cross-team coordination. Again, it's not about the code for a single feature, but the overarching design that affects multiple features or systems.
This is where the writing comes in. A huge part of the staff engineer's job is communicating these large-scale designs. They write the seminal documents, the RFCs, the architectural white papers, that become the reference point for dozens of other engineers. Their ability to articulate a complex technical strategy clearly and persuasively is as important as their ability to architect it in the first place. They are evangelizing a future state and getting buy-in from teams who will have to execute on it.
Amazon takes this even further with their principal engineers at L7 and above. The description says they define the technical direction of the organization and set the long-term vision. This sounds even more abstract and influential.
It is. The principal engineer is often operating on a multi-year timescale. They are looking at industry trends, anticipating future technology shifts, and asking questions like, are the foundational platforms we have today going to support our business goals 3, 5, or even 7 years from now? They might initiate a massive multi-year effort to re-platform a core part of the business or champion the adoption of a new technology paradigm across the entire company. They are the technical conscience and visionary for the organization.
This leads to a crucial point. The metrics for success must be completely different. A senior engineer is judged on project outcomes, system reliability for their services, and maybe the growth of their mentees. How do you measure the success of a city planner?
You measure it by company-wide impact. Did their architectural guidance lead to a 50% reduction in latency across all our products? Did the platform they designed enable 10 new product lines to be launched this year when it would have previously taken 3 years? Did the reliability standards they evangelized prevent a major company-wide outage that could have cost millions? Their success metrics are broad, lagging, and tied directly to top-line business or engineering goals. It's about enabling new capabilities or solving systemic, cross-cutting problems.
It's a profound shift from I shipped this feature to I made the entire engineering organization more productive and our systems more resilient.
It's the ultimate transition from being a maker to being a force multiplier. You're no longer just building the car, you're designing the assembly line that allows thousands of cars to be built efficiently and with high quality.
Let's talk about the structure. The content mentions there may only be a handful of these roles in a large organization, maybe 1 to 3 per org. Why are they so rare?
Because the scope of the role is immense and the required skill set is unique. You need someone with deep, hands-on technical expertise built over a decade or more. They need to have seen multiple systems succeed and, more importantly, fail to understand the subtle trade-offs in architecture. But on top of that, they need incredible communication and influence skills. They often have no direct reports, no formal authority. They have to lead through influence, persuasion, and the sheer strength of their technical arguments.
They have to convince VPs, directors, and dozens of senior engineers that their vision is the right one, without being able to command anyone to follow it.
Exactly. It's a role that requires immense technical credibility and political savvy. You have to navigate complex organizational dynamics, build consensus, and drive change across teams that don't report to you. That combination of deep technical wisdom and high-level strategic influence is exceptionally rare, which is why the roles are few and far between. They are reserved for problems and opportunities that are too big for any single team to solve.
So for the engineer on the ground, the staff engineer is this figure who might appear in their team's design review for a critical new service, challenge their assumptions, and connect their work to a larger, company-wide initiative they might not have even been aware of.
Yes, they are the keepers of the long-term vision. They ensure that the tactical, day-to-day decisions being made on individual teams are not creating a strategic dead end for the company 2 years down the road. They provide the context, the why, behind the technical constraints or requirements that might otherwise seem arbitrary to a team focused on their own roadmap.
It seems the role is fundamentally about balancing the present and the future, the local and the global. They have to understand the immediate needs of a product team while simultaneously steering them towards a more scalable and coherent future state for the entire organization.
That is the essence of it. They are the architects of the organization's technical future, and their blueprints are the design docs, the principles, and the platforms that empower every other engineer to build better, faster, and more reliably. It is the pinnacle of the individual contributor path, a role defined not by the code you write, but by the leverage you create.
It's a fascinating evolution. The journey from junior to senior is about deepening your craft and expanding your scope from a task to a project. But the jump from senior to staff is a phase shift into a new state of matter. It's about changing your very function within the organization, from a builder to an architect of builders.
And that shift in function is a perfect bridge to where our blueprint needs to go next. The staff engineer leads through technical influence, but they operate parallel to the formal management structure. This often creates an interesting dynamic and a close partnership with another key role, the person responsible for the team's execution and the well-being of its engineers.
The line between pure technical leadership and people leadership starts to become a very important boundary to define.
It does, and that's exactly what we'll be mapping in our next episode. We will explore the first step across that boundary, looking at the crucial roles of the tech lead and the hybrid tech lead manager, or TLM. We'll dissect how an organization separates the responsibility for the system from the responsibility for the people, and what happens in teams where one person is asked to do both. It's the next critical fork in the road of our tech org blueprint.
Welcome to Blueprints of a Tech Org, Roles, Ranks, and Roadmaps. In our last episode, we explored the stratosphere of the individual contributor track, the staff and principal engineers. These are the visionaries who operate at an organizational level, influencing architecture and strategy across dozens of teams. They're like the urban planners of a massive, sprawling tech city.
But that leaves a critical question unanswered. If the principal engineer decides a new superhighway system is needed to connect two districts, who designs the individual bridges? Who oversees the crew laying the asphalt day to day, ensuring every bolt is tightened and every support column is sound? Who is on the ground, turning that grand vision into a functioning reality, one feature at a time?
That's precisely the gap we're bridging today. We are zooming in from the citywide view to the single construction site. We'll be dissecting one of the most pivotal roles in any engineering team, the technical lead, or TL. We'll also explore its fascinating and often challenging hybrid sibling, the tech lead manager, or TLM.
This is a critical transition in our series because it's the point where high-level strategy meets the practical, daily execution of writing code. Understanding the tech lead is understanding how great software actually gets built. It's the essential link between architectural theory and shipping a product.
Let's start with the pure play role, the tech lead. The simplest way to define a TL is as the team's ultimate technical owner. This isn't about managing people, it's about owning the system the team is responsible for. Their entire focus is on technical excellence and execution.
I like to think of the tech lead as the lead architect and master builder for a specific project. While a principal engineer might have designed the foundational principles for all buildings in a new development, the tech lead is the one who takes the blueprint for a single complex skyscraper and is responsible for its successful construction. They are on site every day, not just observing from an office.
That on-site presence is crucial. A tech lead is very much a hands-on engineer. Industry data shows they typically spend between 30 and 70% of their time writing code. They aren't just directing traffic, they're in the trenches, writing some of the most critical code, and, more importantly, unblocking other engineers who run into complex technical problems. They are the team's technical backstop.
And a huge part of their role is codifying the how. They are the ones setting the coding standards, establishing the process for design reviews, and making the final call on which tools, libraries, or architectural patterns the team will use for a new feature. They are the authors of the team's technical doctrine. This manifests differently depending on the company culture.
Exactly. At a company like Google, for example, the tech lead is often the formal author of the team's design RFCs, or request for comments. These are detailed documents that propose a technical solution and solicit feedback from the wider engineering community before a single line of code is written. The TL drives that process.
Whereas at Amazon, a TL might be writing deep, narrative-style technical design documents and owning what they call operational readiness. This means the TL is explicitly accountable not just for building the software, but for ensuring it can run reliably, be monitored effectively, and be debugged easily once it's in the hands of customers. It's about owning the entire life cycle of the system, not just the initial creation. The core responsibility is clear. The tech lead is in charge of the system.
So, given that they are so deeply involved in the technical execution, how is their success measured? It's a common misconception to evaluate a TL on their personal coding output. That's not the primary metric.
You're right, it's a trap many organizations fall into. The success of a tech lead is measured by the success of their team's technical output. Think of our master builder again. You don't judge them by how many bricks they laid personally, you judge them by the finished skyscraper. Is it structurally sound? Was it delivered on schedule? Does it have a low number of defects that need fixing after the ribbon-cutting ceremony?
Precisely. The key performance indicators for a TL are things like the team's delivery cadence. Are they shipping features predictably? We also look at the quality of those features. What is the bug rate? How many production incidents are caused by the team's code? And finally, the long-term health of the system. Is the code maintainable? Is the architecture scalable? A great TL is a force multiplier who elevates the technical quality of everyone on the team.
They create a technical environment where the right way to build something is also the easy way. That's their ultimate goal.
Now, let's introduce a complexity that arises, especially in the fast-paced, resource-constrained world of startups and growing companies. This is the hybrid role of the tech lead manager, the TLM.
Ah, the player coach. This role emerges from necessity. In a very small team, say a pre-seed startup with 3 engineers, you don't have the luxury of specialized leadership roles. The most senior engineer naturally starts making architectural decisions. But they also end up interviewing new candidates, doing performance check-ins, and approving vacation time. They become a TLM by default.
And the responsibilities are a direct fusion of 2 distinct jobs: The TLM is expected to do everything we just described for a tech lead: own the architecture, write code, conduct design reviews, while also taking on the core duties of a people manager. This means conducting regular one-on-one meetings, writing performance reviews, handling hiring and promotions, and being responsible for the overall career development and happiness of the engineers on the team.
It's an incredibly demanding balancing act. The urgent, tangible needs of the technology are in constant conflict with the important, long-term needs of the people. A production bug will always feel more immediate than a conversation about an engineer's 5-year career plan. The core challenge of the TLM is to not let the urgent consistently overshadow the important.
This is reflected in their success metrics. A TLM is judged on a dual track. They need to ensure timely launches with high technical quality, just like a TL, but they are also measured on team health metrics. Is the team engaged and motivated? Is turnover low? Are engineers growing in their skills and advancing in their careers? You need positive signals on both fronts to be considered a successful TLM.
This is why the TLM role is often a transitional state for an organization. It works well for a team of, say, up to 5 or 6 engineers. But as the team scales to 8, 10, or 12, the cognitive load becomes unsustainable. The sheer volume of people management tasks, the one-on-ones, the feedback cycles, the recruiting coordination, becomes a full-time job in itself. Simultaneously, the system's technical complexity also grows, demanding a full-time technical owner.
This is a classic organizational inflection point. The player-coach model breaks down because the team needs a dedicated coach focused solely on player development and a dedicated team captain on the field focused solely on executing the plays. Trying to be both at once means you do neither job as well as you could. This is when mature organizations make a conscious decision to split the role.
The TLM is then faced with a career-defining choice. Do they want to follow the technical leadership path and become a dedicated tech lead or even a staff engineer? Or do they want to pursue the people leadership path and become a dedicated engineering manager? This split creates 2 distinct, specialized career ladders that allow for deeper expertise.
Let's summarize the key distinction then. The tech lead is the guardian of the team's technical output. Their world revolves around the system, the architecture, and the code. Their primary focus is on the what and the how of building software.
And the tech lead manager is the hybrid who attempts to own both the system and the people. They own the what, the how, and also the who. It's a role born of necessity in growing teams, but one that typically splits as an organization matures, allowing for greater focus and effectiveness.
That distinction provides a perfect launchpad for our next episode. We've spent this session focused on the leader who is in charge of the system, but we've just alluded to that other equally critical half of the equation, the leader who is exclusively in charge of the people.
Exactly. What does it mean to have your success measured not by system performance, but by team velocity, career growth, and psychological safety? Next time on Blueprints of a Tech Org, we will dive deep into the people leadership track, beginning with that pivotal role that emerges from the TLM split, the engineering manager. We'll break down how they build the culture, processes, and people that power a thriving tech organization.
Welcome. You are listening to Blueprints of a Tech Org, Roles, Ranks, and Roadmaps. In our last discussion, we navigated the complex world of technical leadership, focusing on the tech lead and the hybrid tech lead manager, roles that are fundamentally about owning the how of engineering, the architecture, the code quality, the system itself. But that raises a critical question. If the tech lead is the chief architect of the system, who is the architect of the team? Who is responsible not for the code, but for the coders?
Exactly. It's a fundamental pivot. As an organization scales, you reach a point where the person guiding the technical execution can no longer be the same person guiding the careers, well-being, and growth of the engineers. The cognitive load is simply too great. Today, we're drawing a clear line in the sand and dedicating our focus to the other side of that split, the world of pure people leadership. We'll be dissecting the role of the engineering manager, or EM, and exploring how they fit into the broader engineering organization.
This feels like a crucial distinction. We're moving from the blueprints of the software to the blueprints of the team that builds it. We'll explore exactly what an engineering manager does day to day, how their success is measured, which is often in ways that are less tangible than lines of code, and how this role dramatically differs between a scrappy startup and a tech giant.
And by doing so, we'll see why this role is the bedrock of a healthy, scalable, and high-performing tech organization. It's the transition point from managing projects to truly leading people, and understanding it is key to understanding how modern tech companies build not just products, but sustainable engineering cultures.
So let's start at that moment of divergence. We talked about the tech lead manager, the TLM, who juggles both technical direction and people management. What is the catalyst that forces that role to cleave into two distinct paths, the tech lead and the engineering manager?
The catalyst is growth, pure and simple. A team of 3 or 4 can function with a single leader who codes, architects, and manages. But when that team grows to 8, 10, or 12, the nature of the work changes. The number of one-on-ones doubles. Performance reviews become a significant time investment. Hiring and onboarding new members is a constant process. At the same time, the technical complexity of the product is also increasing, demanding more focused architectural oversight. The hybrid TLM becomes a bottleneck. They are either failing to give the technical roadmap the attention it deserves, or, more commonly, failing to give their people the support they need. The split isn't a luxury, it's a necessity for survival and effectiveness.
This is where the dedicated engineering manager steps in. So if they are handing over the final say on architecture to the tech lead, what does their new mandate become? What fills their day?
Their focus shifts entirely from the system to the humans building the system. Their product is no longer a feature or a service. Their product is the team itself. The core responsibilities are centered around people and process. This includes everything from headcount planning and interviewing to onboarding new hires. But the real meat of the role lies in career development. They are the ones conducting regular one-on-ones, not just for status updates, but to understand an engineer's aspirations, their frustrations, and their long-term goals. They are responsible for writing and delivering performance reviews, navigating the promotion process, and providing constructive feedback.
It sounds like they are the primary interface between the individual engineer and the broader organization's structure and processes, the one who translates corporate needs into individual growth plans.
Precisely. A great framework I've seen breaks the EM's duties into 5 key areas. First, career planning, coaching, and promotions. Second, headcount planning and hiring. Third, overall team planning and ensuring successful delivery, more from a process and resource perspective. Fourth, handling objectives, performance, and feedback loops. And finally, and perhaps most importantly, owning team happiness. The EM is the guardian of the team's health. Are people burning out? Is there friction between team members? Do they have the psychological safety to take risks? That's the EM's domain.
The tech lead removes technical blockers, like a tricky database query or a dependency on another team's API. What kind of roadblocks does an engineering manager remove?
An EM removes human and organizational roadblocks. For example, if an engineer is struggling with motivation, the EM needs to diagnose why. Is it the project? Is it a conflict with a colleague? Do they feel their skills are stagnating? The EM's job is to clear that path, perhaps by finding them a new project, mediating a conflict, or securing a budget for a training course. Another example is process friction. If the team is constantly being derailed by shifting priorities from stakeholders, the EM's job is to act as a shield, pushing back and demanding a clearer, more stable roadmap so the team can actually execute. They manage up and out to protect the team's focus and flow.
I find the idea of an EM delegating architecture fascinating because it requires a great deal of trust. How does that relationship with the tech lead typically work in practice?
It's a partnership, a true separation of concerns. Think of it like a director and a cinematographer on a film set. The director, the EM, is responsible for the overall project, the schedule, the budget, and getting the best performance out of the actors, the actors. The cinematographer, the tech lead, is responsible for the visual execution, the lighting, the camera angles, the technical craft of how the story is told. The EM doesn't tell the TL which lens to use, but they do ensure the TL has the equipment and crew needed. They trust the TL's technical judgment completely. They meet daily, the EM asking, "Are we on track? Does the team have everything it needs?" and the TL responding, here are the technical risks, here's a design choice we need to align on. The EM provides the context, the TL provides the content.
That analogy is incredibly clarifying, and it brings us to a difficult question. How do you measure the success of a director? For a tech lead, you can point to system uptime, performance metrics, or low bug counts. For an engineering manager, the metrics seem softer.
They are, but they are no less critical. The success of an EM is measured by the success of their team. The first, most tangible metric is team velocity. Is the team consistently delivering what they commit to in a sprint or a quarter? This isn't about cracking a whip, it's about creating a smooth, predictable process. The second metric is quality. Are releases stable? Is the team creating a mountain of technical debt, or are they building sustainably? The EM enables this by ensuring there's time for testing, refactoring, and paying down debt. The third and most telling metric is team health. This is measured by things like engineer retention and engagement scores from internal surveys. If you have low turnover and your team reports high levels of satisfaction and psychological safety, your EM is likely doing an exceptional job. A great EM builds a team that people want to join and, more importantly, a team they want to stay on.
And how does this role morph with the size of the company? In a startup with maybe 15 engineers, the EM must be a very different beast compared to an EM at Google managing a team within a 10,000-person engineering organization.
Absolutely. In a smaller startup, an EM is often still expected to be quite technical. They might manage a team of 6 to 8 people, but also act as the de facto tech lead for a part of the system, or even contribute code themselves. They wear multiple hats because the organization doesn't have the scale to support extreme specialization. The reporting lines are also flat. They likely report directly to the CTO or a head of engineering.
Whereas in a large tech company, the roles are much more clearly defined.
Exactly. At a tech giant, an EM typically manages a team of around 8 to 10 engineers and reports to a director of engineering, who in turn manages several other EMs. They are part of a well-defined management structure. Their collaboration is often formalized within a triad model, where the EM, the tech lead, and a product manager form the leadership core for a specific product area. The EM owns the people, the TL owns the tech, and the PM owns the product. They are peers, each with a distinct and respected domain. The EM in this environment spends almost zero time on individual technical contribution and almost all their time on the 5 management pillars we discussed earlier. They are a pure people leader.
You mentioned the director of engineering. This brings up the broader organizational structure. As an EM, you're not just managing your team, you're a node in a larger network. How does an EM manage the flow of information and strategy between their team and senior leadership?
They are a crucial bidirectional conduit. They translate high-level company objectives passed down from the director or VP of engineering into concrete, actionable plans for their team. They answer the question, what does this new company goal mean for us, the front-end platform team, for the next 6 months? But just as importantly, they channel information upwards. They are the voice of the team to leadership. They communicate the team's capacity, flag risks, report on progress, and champion the team's needs. If the team is buried in technical debt and it's slowing them down, the EM is the one who goes to the director and makes the case for a fix-it quarter, armed with data on how it's impacting velocity and morale.
So they aren't just passing messages. They are actively negotiating and advocating for their team's health and resources within the larger organizational context.
Precisely. They are the team's ambassador. They also work horizontally, collaborating with other EMs to manage cross-team dependencies. If your team's feature depends on an API from another team, it's the 2 EMs who connect to align on timelines, define contracts, and resolve any conflicts that arise. In a large organization, this cross-team orchestration is a massive part of the job.
It seems the core takeaway here is that while an engineer's career ladder can continue up the technical track to staff and principal levels, the move to engineering manager is not a promotion in that same line. It's a fundamental career change. You're leaving the path of being an expert builder and starting on a new path of being an expert multiplier of builders.
That is the perfect way to put it. The success of a senior individual contributor is their direct impact. The success of an engineering manager is the combined impact of their entire team. They achieve their goals through the work of others. It requires a completely different skill set: empathy, communication, coaching, strategic thinking, and a genuine passion for helping people grow. The best EMs derive their satisfaction not from solving a complex technical problem themselves, but from creating an environment where their team can solve it. Their legacy is the strength, skill, and success of the people they've managed.
We've now established a clear picture of the people who build the tech, the individual contributors, and the two primary leadership tracks that guide them: the tech lead for the system and the engineering manager for the team. But this whole structure exists to serve a purpose: to build a product. That raises the next logical question: who decides what gets built and why?
And once that decision is made, in a large organization with dozens of interconnected teams, who keeps that colossal effort on track, making sure all the pieces come together at the right time? That sounds like a whole different set of blueprints.
It certainly does. On our next episode of Blueprints of a Tech Org, we'll dive into that very topic. We'll explore the critical roles that sit at the intersection of business, technology, and execution: the product manager and the technical program manager. We'll find out who owns the what and who owns the when. Welcome to Blueprints of a Tech Org: Roles, Ranks, and Roadmaps. In our last episode, we unpacked the role of the engineering manager, the leader focused on the people and the health of the engineering team itself. They are the ones answering the question: do we have the right people, and are they set up for success?
Exactly. We established that the EM is fundamentally about the who, but that leaves a couple of massive questions unanswered on our blueprint. If the EM handles the who and the engineers are deep in the how of writing code, who decides what gets built in the first place? And more importantly, why?
And as organizations grow, it's rarely just one team building one thing. You have multiple teams, multiple features, all moving at once. So who ensures all those moving parts, all those different hows, come together into a single, cohesive, and on-time delivery?
Those questions take us directly into the heart of today's discussion: a critical axis of power and influence in any tech organization: the distinction between product and program. We'll be mapping the roles of the product manager, or PM, and the technical program manager, the TPM.
Understanding this divide is essential. It's where the strategic vision of a company gets translated into the day-to-day work of engineering teams. Getting this relationship right is the difference between a company that ships beloved products and one that just ships code.
Let's start with the product manager. If you've ever wondered who decides what button goes where, what feature gets prioritized, or even what a product is meant to achieve, you're thinking of the PM. They are the designated owner of the what and the why.
What does that ownership actually entail? It sounds like a huge amount of responsibility.
It is. The PM's primary function is to be the voice of the customer inside the organization. They are responsible for deeply understanding user needs, market trends, and business goals. They synthesize all of that into a compelling product vision and a prioritized roadmap. They are the ones writing the detailed requirements and, crucially, defining what success looks like by setting key performance indicators, or KPIs, things like user growth, engagement rates, or revenue. Their entire job is to ensure the team builds the right product.
So they're not just coming up with ideas. They're building a business case for a feature, backed by research and data.
Precisely. Think of a PM as the architect of a custom-built home. The architect's job isn't to hammer the nails or pour the concrete. That's the engineering team. And they don't manage the day-to-day schedules of the electricians and plumbers. That's the engineering manager. The architect's obsession is with the future homeowner, the customer. They conduct countless interviews to understand the family's lifestyle, their needs, their desires. Why do you need 4 bedrooms? What kind of morning sun do you want in the kitchen, and why?
They use that deep understanding of the why to create the blueprint, the what. This blueprint details the layout, the materials, the flow of the house. It's the master plan that everyone else works from.
And the architect's success isn't measured by how quickly the house is built or how clean the construction site is. It's measured by whether the family is happy living there years later. Does the house meet their needs? Does it solve their problems? That's the business outcome. For a PM, success is measured by product adoption, customer satisfaction, and hitting revenue targets.
You see this play out in the methodologies of top tech companies. At Amazon, for example, PMs are famous for the working backwards process. Before a single line of code is written, the PM writes an internal press release or a PR FAQ announcing the finished product.
It's a powerful tool. It forces absolute clarity on the customer benefit. Who is this for? What problem does it solve? What is the customer experience? If you can't write a compelling press release, you probably don't have a feature worth building. It anchors the entire development process in the why.
And at a company like Meta, PMs are famously data-driven, almost singularly focused on metrics like user growth and engagement. Every decision is framed around how it will move those specific needles. The why is growth, and the what is whatever feature is hypothesized to achieve it.
So the PM holds the vision. But as you mentioned, modern products aren't a single house. They're more like a sprawling, interconnected city. You have the water department, the electrical grid, the roadworks, the transit system. All of these are complex engineering projects in their own right, and they all have to work together. If the road is paved before the sewer lines are laid, you have a massive, expensive problem.
This is where our second role comes in, the Technical Program Manager, or TPM. If the PM is the architect of the vision, the TPM is the master city planner and logistics coordinator of the execution. Their domain is the how and the when, but at a macro, cross-functional level.
While a PM is focused on a single product or feature team, a TPM's purview spans multiple teams, sometimes an entire organization. Their job is to manage the complex web of dependencies, timelines, and risks that arise when you're executing a large-scale program. They ensure that the sewer lines are, in fact, installed before the road is paved.
What does that look like in practice? Are they just managing a giant Gantt chart?
That's a part of it, but it's much more. A TPM is a master of communication and risk mitigation. They run the scrum of scrums, where representatives from different teams come together to sync up. They identify potential roadblocks weeks or months in advance. They ask the hard questions. Team A's API is scheduled to be delivered in Q3, but Team B needs it in late Q2 to hit their launch date. What's the plan? They don't just track status, they actively solve for conflicts and clear the path for delivery.
They are the operational connective tissue.
I like to think of the TPM as an air traffic controller at a busy international airport. The PM, in collaboration with the business, has defined the destination for each flight, the what and why. The engineering teams are the skilled pilots flying the planes. The EM ensures the pilots are trained, healthy, and the planes are well maintained. The TPM is in the control tower, looking at the entire system.
They see all the planes on the radar. They know their flight paths, their speeds, their altitudes.
Exactly. Their job is to ensure that all these planes take off on schedule, that their paths don't cross dangerously, that they have clear runways to land, and that the whole system operates smoothly and predictably. Their success is measured by on-time arrivals, the absence of near misses or collisions, and clear, constant communication to all pilots. A great TPM makes an incredibly complex operation feel routine and under control.
The value of that role becomes incredibly clear in large organizations. A company-wide initiative like a GDPR privacy rollout or a major migration from on-premise data centers to the cloud would be impossible without TPMs to orchestrate the work of dozens, if not hundreds of teams.
And it's not just big tech. In traditional enterprise, the program manager role is often even heavier, dealing with external vendors, hardware deployments, and rigid compliance or regulatory requirements. Their success is measured in on-time, on-budget project delivery and a clear audit trail of communication.
So let's put them side by side. The PM is focused on the customer, the product vision, and the business outcome. The TPM is focused on the internal machinery, the execution plan, and the delivery milestones. How do they avoid stepping on each other's toes?
By having clearly defined lanes and a deep mutual respect for each other's function. The PM owns the what and why. The TPM owns the how and when of the cross-team execution. The PM might say, market research shows that our top priority should be building a real-time collaboration feature to increase user stickiness by 15%.
And the TPM would respond by saying, understood. To build that, the platform team needs to deliver the new WebSocket service by May 1st. The front-end team has a dependency on that for their component library, which is due June 15th. And the mobile team is blocked until both are complete. There's a risk in the platform team's timeline because of a planned database upgrade. Here is my proposed mitigation plan to de-risk the schedule.
It's a partnership. A product can be delivered flawlessly on schedule, a huge win for the TPM, but if it doesn't solve a real user need, it will fail in the market, and that's a failure for the PM.
Conversely, a PM might have a world-changing product vision, but if the execution is a chaotic mess of missed deadlines and cross-team conflict, it may never see the light of day. That's a failure of the program. They need each other to be truly successful.
This brings us back to a concept we've touched on before, the leadership triad. In a healthy tech organization, you often have the engineering manager, the product manager, and sometimes the technical program manager working as a tight-knit leadership group for a product area. The EM focuses on the people, the PM focuses on the product, and the TPM focuses on the program. Together, they ensure the organization is building the right things with the right people in the right way.
It's a beautiful separation of concerns that, when it works, acts as a powerful force multiplier for the entire engineering organization. The PM protects the team from building the wrong thing, the TPM protects the team from chaotic execution, and the EM protects the team's health and growth.
When you're trying to understand a tech company, mapping out how these roles interact is one of the most revealing things you can do. It tells you what they value, how they make decisions, and how they turn ideas into reality.
So, as a key takeaway, while both roles are critical for shipping software, they operate on different planes and are measured by different yardsticks. Product management is about defining the right destination, ensuring the product solves a real customer problem and meets business goals.
And program management is about ensuring a safe and predictable journey to that destination, especially when it involves a whole fleet of teams. They are the masters of execution, ensuring the organization can deliver on its promises reliably and at scale.
We've now seen how individual contributors grow, how tech leads guide the technical direction, and how engineering managers foster the people. We've also just mapped how product and program managers steer the what and the how. But who manages the managers? Who is looking at the blueprint not just for one team or one program, but for an entire department?
Who is responsible for ensuring that all these different product teams, these individual neighborhoods, are building towards a coherent, unified vision for the entire city?
That question takes us up another level in the organizational blueprint. In our next episode, we will explore the role of the Director of Engineering, the leader of leaders who translates executive strategy into engineering reality and starts to shape the long-term technical roadmap for an entire domain. Welcome to Blueprints of a Tech Org, Roles, Ranks, and Roadmaps. In our last episode, we untangled the complex dance between product managers and technical program managers, the people who define the what and why versus those who master the how and when of execution. We saw how they operate at the team and project level to bring a product to life. But this raises a critical question. What happens when an organization grows beyond a handful of teams? When you have 5, 10, or even 50 teams, each with their own roadmap and priorities, who ensures they aren't all building separate, disconnected empires? Who is conducting the entire orchestra rather than just playing a single instrument?
That's the perfect way to frame it. The challenge of scale is one of the most difficult transitions for any tech company. A process that works for a 20-person startup shatters when you hit 200 engineers. This is where a new layer of leadership becomes not just helpful, but absolutely essential. Today, we're moving up the leadership ladder to map out the role of the Director of Engineering. We'll explore how this role is fundamentally different from an engineering manager, what their core responsibilities are around strategy, people, and process, and how their success is measured not in features shipped by one team, but in the collective impact of an entire department.
Exactly. This isn't just a promotion from engineering manager, it's a phase shift in responsibility. We're moving from leading people who write code to leading people who lead people. It's a critical junction on the career roadmap, and understanding it is key to understanding how large tech organizations actually function and scale effectively.
Right. So at its core, the Director of Engineering is a manager of managers. An engineering manager, or EM, is focused on a single team. They're deep in the weeds of a specific product or service. They manage individual engineers, unblock technical problems, and ensure their team's sprint goals and project milestones are met. Their world is the team's immediate execution. The director's world is the entire department or a large product area. They don't manage individual contributors anymore. Their direct reports are the engineering managers.
So their primary focus shifts from the code and the coders to the health, alignment, and performance of multiple teams as a cohesive unit.
Precisely. This shift manifests in 3 key areas. The first is a move from tactical execution to strategic leadership. The C-suite or VP level sets the high-level company objectives. For example, increase market share in Europe by 15%, or improve platform reliability to 99.99%. The director's job is to translate that high-level business or product goal into a concrete, multi-quarter technical strategy for their entire department. They work with their EMs to define the specific roadmaps, initiatives, and resource allocations needed to hit those targets. They are the crucial bridge between executive vision and engineering execution.
This sounds like where the concept of OKRs, objectives and key results, becomes really critical. The director would be responsible for setting the department-level OKRs that cascade down from the company's goals. And each EM would then set team-level OKRs that align with the directors.
That's exactly it. The second major area is organizational and people leadership, but at scale. A director isn't just mentoring engineers, they are coaching and developing their engineering managers. They're teaching them how to be better leaders, how to handle performance issues, how to recruit effectively, and how to manage their own team's budgets. The director is also responsible for the architectural design of the organization itself. They are constantly asking, do we have the right team structure? Are our teams aligned with product areas effectively? Do we need a new platform team to solve common problems for everyone? They own headcount planning and the budget for their entire group, making the case to senior leadership for why they need to hire 10 more engineers next year and how that investment will pay off.
So they're not just building a product, they are consciously designing and building the machine that builds the product, the organization itself.
That's a great way to put it. And the third piece is process and policy. An EM might decide how their team runs stand-ups or does code reviews. A director, on the other hand, establishes the rules of the road for the entire department to ensure consistency and quality. They might create a standardized on-call rotation policy, define the stages of a production readiness review, or mandate a specific release cycle. Their goal is to create scalable, repeatable processes that allow all their teams to operate efficiently and predictably without having to reinvent the wheel. It's about building systems that enable success across the board. The Lead Dev platform puts it well, saying a director's role is to lead and mentor engineering managers, align technology with company objectives, and oversee engineering delivery. That really covers the strategic, people, and execution oversight functions.
I think an analogy would be helpful here. How can we visualize this shift from the ground-level view of an EM to the 30,000-foot view of a director?
Let's think of it like building a new city district. The engineering managers are the foremen on individual construction sites. One is in charge of building the residential tower, another is building the office building, and a third is building the park. They are on site every day, managing their crew of workers, the engineers, ensuring the foundation is poured correctly, the steel frame goes up on schedule, and the quality of the work is high. They are deeply concerned with the blueprints and timelines for their specific building.
They're solving the immediate, tangible problems of their project. Does the crane have fuel? Are the right materials on site? Is the team on track to finish the 3rd floor this week?
Exactly. Now, the director of engineering is the city planner for the entire district. They aren't on any single construction site pouring concrete. They are in the planning office with a map of the whole area. Their job is to make sure the district works as a cohesive system. They decide where the roads should go to connect all the buildings. They ensure the plumbing and electrical grid, the shared infrastructure, can support all the new structures. They negotiate with the city council, product and design leadership on the overall vision for the district. They are worried about things like, does our road network have enough capacity for future traffic? Which translates to, is our technical architecture scalable? Or, do we have the budget and workforce to build a subway station here next year, which is headcount and resource planning.
So the foreman, the EM, succeeds when their building is completed on time and to spec. The city planner, the director, succeeds when the entire district thrives, when people can move between buildings easily, when the infrastructure is reliable, and when the district as a whole achieves its economic and social goals.
You've got it. The director's success metrics are fundamentally different. They're not measured on a single team's velocity. They're measured on multi-team outcomes. Did their entire department deliver on its quarterly and annual roadmap commitments? Have key quality and reliability metrics for all their services improved? And critically, are they retaining and growing their leadership talent? A great director produces great EMs, who in turn build great teams. Their impact is magnified through others.
And how does this role change depending on the context of the company? A director at a 100-person startup must feel very different from a director at Google.
Absolutely. In a mid-stage startup, say 100 to 500 people, the director of engineering is often a very hands-on role. They might still be deeply involved in major architectural decisions and might be the primary person establishing the company's first real engineering processes. They're often responsible for building the management layer from scratch, hiring the first few EMs, and coaching the founding engineers into leadership roles. There's often only one director who reports directly to the CTO or VP of engineering.
They are setting the foundation for future scale.
Correct. In a big tech company like Meta or Amazon, the scale is mind-boggling. A director might own a significant product area, like Instagram Stories or AWS S3's core storage tier. They could have 5 to 10 engineering managers reporting to them, who in turn manage a total of 50 to 150 engineers. Their role is much more about managing complexity, navigating a large organization, and influencing other groups. They spend a huge amount of their time in strategy meetings with their peers, directors of product, design, and data science, to align on multi-year roadmaps. They are operating like the general manager of a small business unit within the larger corporation.
And in a more traditional enterprise, say a large bank or retailer undergoing a digital transformation,
there, the director's role often carries a heavier emphasis on budget management, vendor relationships, and risk and compliance. The planning cycles are often longer and more formal. They might be managing a mix of in-house teams and external contractors, and a significant part of their job is ensuring that all engineering work adheres to strict regulatory and security standards. The focus is often as much on stability, security, and predictability as it is on innovation.
So in all these contexts, the common thread is that they operate at the intersection of technology, people, and business strategy, but the specific emphasis changes with the environment. Which brings us to their place in the hierarchy. You mentioned they report to a VP or CTO.
Yes, that's the typical structure. The director of engineering sits in senior management. They are the key communication conduit between the executive level and the teams on the ground. They take the company's strategic vision from the VPE or CTO and translate it into actionable plans. And they bubble up the resource needs, risks, and innovations from their teams back to the executives. They are also peers with directors in other functions. The director of engineering, director of product management, and director of UX design often form a leadership triad responsible for the holistic health and success of a product division.
That triad seems essential for ensuring that the business goals, user experience, and technical feasibility are all balanced and aligned at a high level, not just within a single team.
It's non-negotiable in a healthy organization. Without that peer-level alignment, you get departments that are optimized in isolation but fail to deliver a cohesive product or strategy. The director is the glue that holds the engineering part of that alignment together across multiple teams.
So, to summarize the journey, the transition to director of engineering marks a crucial pivot from leading a team to leading an organization. It's a move away from the day-to-day tactical execution and toward a focus on long-term strategy, organizational design, and the development of other leaders. It's about creating the environment, processes, and structure that allow dozens or hundreds of engineers to do their best work in a coordinated fashion.
Exactly. You graduate from being a foreman focused on a single building to a city planner designing the entire district. Your tools are no longer code reviews and stand-ups, but rather strategic roadmaps, headcount plans, and coaching sessions with your managers. You succeed when the whole system succeeds. It's a role defined by leverage and scale, where your primary function is to enable the success of others.
And that role, the director, is still accountable to someone higher up. They are executing a strategy that is often set at an even broader company-wide level. This naturally leads us to the pinnacle of the engineering organization, the executives. Who does the director report to, and what do those roles even mean? In our next episode, we will blueprint the two most senior technical roles in a company, the VP of Engineering and the Chief Technology Officer. We'll explore the critical differences between them and figure out who is ultimately responsible for the people and who is responsible for the technology.
Welcome to Blueprints of a Tech Org, Roles, Ranks, and Roadmaps. In our last episode, we explored the Director of Engineering, the leader who manages multiple teams and translates high-level strategy into departmental execution. But what happens when the organization grows beyond a single department? Who is at the very top, steering the entire technological ship? And perhaps more importantly, who is looking ahead, charting the course through the fog of future trends to ensure that ship is not just running smoothly, but sailing towards the right horizon?
That's the critical question, and it brings us to the pinnacle of the tech leadership ladder. Today, we're demystifying two of the most senior and often most confused roles in any tech company, the VP of Engineering and the Chief Technology Officer. While the titles are sometimes used interchangeably, they represent two distinct and vital functions. We'll break down the VP's intense focus on execution and the CTO's expansive focus on vision. We will also examine their core responsibilities, how their success is measured, and how these roles fundamentally shift depending on whether you're in a scrappy startup or a tech behemoth.
It's a crucial distinction. Misunderstanding this split can lead to strategic drift or operational chaos. This is the final step in the core leadership chain we've been building, moving from individual contributors all the way to the executive suite.
Exactly. At its core, the difference can be distilled down to two words: execution versus vision. The VP of Engineering is the master of the how and the now. They are fundamentally responsible for the effective, efficient, and scalable delivery of the company's products. This role is internally focused, ensuring the entire engineering organization is a well-oiled machine.
So the VPE is accountable for turning the company's goals into reality. What does that look like on a day-to-day basis?
It covers three primary domains. First, people. The VP owns the overarching hiring strategy, designs the career ladders and organizational structure, and manages the senior engineering leaders, like the directors we discussed previously. They are the ultimate stewards of engineering culture and talent. Second, process. The VP defines how the organization builds software. They establish the engineering-wide processes for development, quality assurance, and releases. They ensure these processes are efficient and scale as the company grows. And third, delivery. The VP is ultimately accountable for the execution of the product roadmap. They work with product and business leaders to allocate resources, manage budgets for the entire department, and ensure that teams ship high-quality products on time.
It sounds like a role grounded in operational excellence.
Precisely. Think of the VP of Engineering as the Chief Operating Officer for a complex factory. This COO doesn't necessarily invent the next revolutionary car model. That's more in the product and CTO domain. Instead, they are obsessed with the factory floor. They design the assembly line for maximum efficiency and quality. They ensure the workers, the engineers, are highly skilled, well-equipped, and motivated. They are responsible for ensuring the cars roll off that line on schedule, on budget, and without defects. Their world is the operational reality of the organization.
That's a powerful analogy. So if the VPE is perfecting the factory, who decides that the factory should pivot from building gasoline cars to electric vehicles because of a long-term shift in the market?
Now you're talking about the Chief Technology Officer. Where the VP is focused inward and on the present, the CTO is focused outward and on the future. The CTO is the senior executive responsible for the company's long-term technology vision and innovation. They are constantly scanning the horizon for emerging trends, competitive threats, and new technological opportunities that could transform the business.
This sounds far more strategic and less about day-to-day management.
Absolutely. The CTO's responsibilities are about setting direction. First, vision and strategy. They answer the big questions. How will advancements in AI, decentralized systems, or quantum computing affect our industry in the next 5 to 10 years? They set the multi-year technical roadmap. Second, high-level architecture and R&D. The CTO makes the foundational technology decisions that will have ramifications for years to come, such as selecting a primary cloud provider or deciding on a core architectural pattern. They also often oversee research and development efforts. Third, they are often an external-facing figure, representing the company's technology to investors, key partners, and the public at industry conferences.
Following your factory analogy, what role does the CTO play?
The CTO is the head of long-range strategic planning and advanced research. They aren't on the factory floor optimizing the current assembly line. They're out in the world, visiting advanced materials labs, attending energy conferences, and analyzing global market trends. They are the one who returns to the board and says, internal combustion is a dead end. The future is electric, and here is the decade-long strategic plan to retool our entire company to not just compete, but to lead that revolution. They are concerned with what the factory should be building in 5 years, not just how well it operates today.
It makes perfect sense when you lay it out that way. But in the real world, especially in early-stage companies, these lines must be incredibly blurry.
They're almost non-existent at the beginning. In a startup, the founding CTO is usually the first senior technical hire and has to be both the VP and the CTO. They write the initial code, make the first architectural decisions, hire the first few engineers, manage the daily tasks, and simultaneously try to maintain a long-term vision. But as the engineering team grows to 20, 30, or 50 people, that model breaks. A single person cannot effectively manage the performance of 50 engineers while also dedicating serious thought to the 5-year technology strategy. This is the critical inflection point where a mature startup hires a dedicated VPE to take over the people in execution, freeing the CTO to focus entirely on the long-term technology vision.
So the hiring of a VPE is a key signal of an organization's maturity and scaling. How does this dynamic play out in the opposite end of the spectrum, in big tech companies?
In FANG-level companies, these roles are highly specialized and clearly delineated. A large corporation might have multiple VPEs, each responsible for a massive division like cloud infrastructure or advertising platforms, overseeing thousands of engineers. The CTO role, in contrast, can become very specific. It might be a pure research function looking at 10-year horizons, or it could be focused on a single high-stakes bet, like Meta's CTO driving emerging tech platforms. The title signifies the most senior technologist, but their scope can be either incredibly broad or deeply specialized.
Let's bring this back to accountability. With such different purviews, how is success measured for each role? For the VPE, it seems more straightforward.
It is. A VPE success is tied to tangible, operational metrics. Did the product portfolio launch on time and to specification? You can measure engineering productivity through things like feature throughput and defect rates. And you can measure the health of the organization by looking at talent metrics like hiring velocity and employee retention. It's about the measurable output and health of the engineering department right now.
For the CTO, that seems much harder. You can't put a quarterly KPI on a 5-year technology bet.
Exactly. Measuring a CTO's success requires a much longer lens. Their performance is judged on strategic outcomes. Did the architectural choices they made 3 years ago enable the company to scale seamlessly or pivot into a new market? Is the company recognized as a technology leader in its field? The metrics are about hitting major strategic milestones, the return on investment from R&D initiatives, and, perhaps most importantly, avoiding technological obsolescence because the CTO saw the future coming and prepared the company for it.
So, to summarize our blueprint of the executive suite, if the director from our last episode is the captain of a ship in the fleet, the VP of engineering is the fleet admiral, ensuring every ship is properly staffed, supplied, and sailing in perfect formation to execute the current mission.
And the CTO is the grand strategist back at Naval Headquarters, poring over global maps, intelligence reports, and atmospheric charts. They decide which ocean the fleet needs to sail to next year and what revolutionary kind of ship they'll need to build for the conflicts of the future. A brilliant strategist is useless with a dysfunctional fleet, and a perfectly efficient fleet sailing toward irrelevance is a wasted effort. You need both.
A perfect distinction. The VPE's focus is inward on people and execution. The CTO's is outward and forward on technology and vision.
And grasping that fundamental split is essential for anyone aspiring to the highest levels of technical leadership.
This brings us to the close of our journey up the core leadership ladder. In our final episode, we'll zoom out to complete the blueprint, looking at the crucial supporting functions and the broader industry context that shapes all these roles.
That's right. We'll explore the indispensable worlds of DevOps, SRE, and platform engineering. We'll cover the guardians of quality in QA and SDT roles, the vast and expanding universe of data and AI professionals, and the critical function of design and UX that ensures we build products people love.
And we'll tie it all together by comparing how all these roles, from a junior engineer all the way to the CTO, look and feel different in the dynamic environments of a startup, the structured world of big tech, and a traditional enterprise. It will be the capstone to our series. We hope you'll join us. Welcome back to Blueprints of a Tech Org, Roles, Ranks, and Roadmaps. For our 10th and final episode, we're moving from the executive suite we discussed last time, the grand strategists like the CTO, and the operational commanders like the VP of Engineering, to explore the foundational pillars that the entire organization is built upon.
Exactly. We've mapped out the command structure, but what about the specialized forces that make everything possible? An army is more than its generals. Today, we're diving into the crucial supporting roles that ensure the code actually runs, that it's high quality, that it's powered by intelligent data, and that users actually love it. We'll be covering the world of DevOps, SRE, and platform engineering, the quality guardians in QA and SDT, the incredibly diverse ecosystem of data and AI roles, and the champions of the user in design and UX.
And to bring our entire series full circle, we'll then place all these roles, from the junior engineer all the way up to the CTO, into their real-world habitats. We'll compare how these blueprints look drastically different in the chaotic, high-growth environment of a startup, the structured, scaled world of big tech, and the process-driven landscape of a traditional enterprise.
It's the final piece of the puzzle. Understanding these supporting functions and the context they operate in is what separates a theoretical org chart from a living, breathing, and successful technology organization. So let's start with the roles that form the bedrock of any modern digital product, the people who keep the lights on.
You're talking about the folks who make sure our applications are always available, scalable, and that developers can ship code without fear. This is the domain of DevOps, Site Reliability Engineering, SRE, and Platform Engineering. These terms are often used interchangeably, but they represent distinct philosophies and functions.
That's right, and it's a critical distinction. Think of it like building and racing a Formula One car. The product engineers are the designers and mechanics building the core engine and chassis. The DevOps engineers are like the hyper-efficient pit crew, building the automated processes, the CI/CD pipelines, to get the car onto the track and serviced with new parts as quickly and reliably as possible. Their focus is on streamlining the entire delivery lifecycle.
So their success is measured by things like deployment frequency, how often can we safely release new code, and lead time for changes.
Precisely. Then you have the Site Reliability Engineers, or SREs. Continuing the analogy, the SREs are the race day telemetry and reliability team. They are software engineers focused squarely on the operational aspects of the car during the race. They live and breathe metrics like uptime and latency defined by service level agreements, or SLAs. They use a data-driven approach to ensure the car can run for 24 hours straight without a catastrophic failure. A key metric for them is mean time to repair, or MTTR. When something breaks, how fast can we fix it?
And this is the philosophy pioneered at Google, treating operations as a software engineering problem. They even have the concept of an error budget, which quantifies the acceptable level of unreliability. If you burn through your error budget, all new feature development halts until reliability is restored.
Exactly. It creates a powerful self-regulating system. Finally, you have platform engineers. They are the ones who build the factory where the race cars are made. They create internal tools, paved roads, and self-service infrastructure that allows all the product teams to build and deploy their services without having to become experts in cloud infrastructure or Kubernetes themselves. They build the platform that accelerates everyone else.
And the context here is key. In a small startup, one senior backend engineer might be doing all of this, managing the AWS account, setting up the deployment scripts, and responding to pages at 3 a.m. In a FANG company, you have massive, distinct teams for SRE, DevOps tooling, and the internal developer platform, each with a very specific mandate and deep specialization.
Which leads us from does it run to does it work correctly? Once the system is reliable, we need to ensure it's high quality. This brings us to the guardians of quality, QA engineers and software development engineers in test, or SDT.
Another area with evolving titles. Many people picture a QA engineer as someone manually clicking through an application following a test plan. While that's part of the history, the modern role, especially the SDET, is far more technical.
Absolutely. The traditional QA engineer is focused on test planning, manual testing, and exploratory testing to find edge cases a developer might miss. They are the user's advocate, ensuring the product is functional and intuitive. But the SDT is fundamentally a developer whose product is the testing framework itself. They write code to automate testing.
So they build the automated regression suites, performance tests, and security scans that run every time a developer tries to merge new code. Their work is what allows DevOps to be fast. You can deploy frequently because you have a robust, automated safety net.
Here's an analogy. A manual QA engineer is like a meticulous building inspector who walks through a newly constructed house, checking every window, faucet, and electrical outlet by hand to ensure it meets the code. An SDET is the engineer who designs and builds an automated factory system that stress tests every pipe for leaks and every wire for faults before they are even installed in the house. One is about inspection, the other is about prevention through automation.
The success metrics reflect that difference. You're looking at things like test automation coverage, what percentage of our code is verified by automated tests, and the bug escape rate, which measures how many bugs are found by customers in production versus being caught by the test suites. In modern tech firms, these SDETs are often embedded directly within the development teams, making quality a shared responsibility from day one.
That integration is crucial. Now, let's move from the machinery and the quality checks to the fuel that powers modern tech, data. The landscape of data roles is perhaps the most complex and specialized of all.
It truly is an ecosystem. We have data engineers, analytics engineers, data scientists, machine learning engineers, applied scientists, and research engineers. Where do we even begin to untangle that?
We can think of it as a journey from raw data to intelligent action. It all starts with the data engineer. They are the architects and plumbers of the data world. They build and maintain the robust, scalable pipelines that extract data from various sources and load it into a data warehouse or data lake. Their job is to make sure clean, reliable data is available.
So they are the foundation. Without them, no one else can do their job.
Correct. Next are the analytics engineers, or business intelligence analysts. They sit between the raw data provided by data engineers and the business users. They take that data, clean it, model it, and create the core dashboards and metrics that the company uses to track its health.
This sounds a lot like what a data scientist does. What's the difference?
It's a spectrum, but the core difference is that a data scientist goes beyond describing what has happened to predicting what will happen. They use advanced statistical techniques and machine learning to design experiments, build predictive models, and answer ambiguous, high-impact business questions.
And that's where the machine learning engineer comes in. They are the ones who take a model that a data scientist has built, say a recommendation algorithm prototyped in a notebook, and productionize it. They rebuild it as a scalable, low-latency, production-grade service that can handle millions of requests. They bridge the gap between research and reality.
Perfectly put. Finally, you have the more research-focused roles. An applied scientist is often embedded within a product team, using research and modeling to solve a specific applied problem, like improving the ranking algorithm for a search engine. A research scientist, often with a PhD, is more forward-looking. They may be developing entirely new algorithms or techniques, with their work often leading to academic publications. And a research engineer builds the complex tooling and systems that enable that cutting-edge research.
The context here is huge. A startup might have a single data person trying to do all of this at once. A large tech company like Meta or Google has massive, specialized teams for each of these functions, supported by an enormous internal data platform. The success of all these roles ultimately comes down to the business impact of their models and insights.
And all this incredible technology, data, and infrastructure is ultimately in service of one thing. This brings us to our final group of supporting roles: design and UX.
The people who ensure the product is not just functional and reliable, but also usable and even delightful. Here, the primary roles we see are the product designer and the UX researcher.
Yes, and they are distinct but deeply collaborative partners. The UX researcher is the voice of the user. They are the investigators who validate the team's assumptions through qualitative methods like user interviews and usability testing, and quantitative methods like surveys and data analysis. Their job is to provide deep insights into user needs, behaviors, and pain points.
So they answer the question, are we building the right thing?
Exactly. The product designer, sometimes called a UI/UX designer, then takes that research and answers the question, how do we build the thing right? They are responsible for the entire user journey, creating wireframes, interaction flows, and high-fidelity visual mock-ups of the user interface.
You can measure their success with usability metrics, like time to complete a task or user satisfaction scores, as well as the outcomes of A/B tests on different designs. The organizational importance of design varies wildly. At a company like Apple, design is at the absolute core of the company. In other places, a single designer might be stretched thin, supporting several engineering teams at once.
A great way to think about it is this. The UX researcher is the anthropologist, studying how people live to understand their deepest needs. The product designer is the architect, who uses those anthropological findings to design a building that is not only beautiful, but perfectly serves the community's daily life. They must work hand in hand.
So we've now covered the full spectrum, from the executive layer down to the specialized supporting pillars. Let's tie it all together by looking at how these roles manifest in different industry contexts. A staff engineer at a startup has a very different life from a staff engineer at Google or a large bank.
Completely different. Let's start with startups. The defining characteristic here is fluidity. Roles are broad, and you're expected to wear multiple hats. An engineer might write code, deploy it to production, and talk to customers for feedback all in the same day. The CTO is often still writing code. Speed is valued above all else. The goal is to iterate quickly to find product-market fit before the funding runs out. The hierarchy is flat and process is minimal.
Then you have the other end of the spectrum, FAANG and big tech. This world is defined by specialization and scale. Roles are very narrowly and clearly defined. There are established processes for everything, from code reviews to promotions. You work on a two-pizza team, small and agile, but within a massive, complex organization. The goal is to innovate and execute reliably for hundreds or even billions of users.
And finally, we have traditional enterprises. Think large banks, insurance companies, or industrial giants undergoing digital transformation. Here, the defining traits are process, stability, and risk management. You'll often see more waterfall or hybrid agile development processes. There are more layers of approval and a heavier focus on compliance and regulation. Titles like IT project manager are common, and there's often a larger program management office to coordinate complex, long-running projects.
So as we close out this series, it's clear that a tech organization's blueprint is not one size fits all. It's a dynamic structure shaped by the company's mission, scale, and maturity. We've journeyed from individual contributor ladders in engineering through the branching paths of technical and people leadership, across the critical functions of product and program management, up to the executive floor, and now through the essential supporting pillars that hold it all up.
The key takeaway from our entire series is that a tech organization is a complex ecosystem. Each role has a purpose, and they all depend on each other. Understanding these roles, their responsibilities, and how they interact within different industry contexts is the key to navigating your own career roadmap and to appreciating the incredible collaborative effort it takes to build the technology that shapes our world.
It has been a pleasure mapping out these blueprints with you. And to our listeners, thank you for joining us on this 10-episode journey through the roles, ranks, and roadmaps of the modern tech org.